Welcome back to our study of differential equations. And remember, when we solve a differential equation, or first of all, we use a differential equation to model some real-life system, for instance, population growth or projectile motion. And then we model changes, as in this equation here. Okay, we model changes. We say the change in y with respect to x is equal to some function of x and y. Now, when we solving one means finding what? Finding what? Well, it means we're going to find y is equal to some function of x. That's what we're trying to find, okay? That's what your homework will be tonight. You'll be given a differential equation, and you'll need to solve it. So let's go through the steps of solving a separable differential equations, okay? These are simple ones to solve, and there's many more techniques to solving differential equations. And if you, in your second year of college calculus, you'll take a course called Diffy, so that'll be the cool way to say the course for differential equations. But we'll just get kind of an introduction to this by showing you how to solve these types here. Okay, so here's a given problem. We want to solve this differential equation, and here it is. And if you're given in order to solve a differential equation, you have to be given a derivative equation, and you have to be given a point. If you're not given a point, you're going to have some kind of plus c or general equation. If you're given a point on the curve, you're going to get a particular solution. So anyway, let's get to work on this. And what I'm going to do here is go through these steps. On the left, you're going to see in general how to solve these. On the right, I'm going to do a specific example, the example I gave you. So when you see one of these questions in a free response question too, as maybe a motivation, they're always worth a lot of points, always worth 5 points. So the steps to solving these equations are very important. So the first thing I'm going to do is I'm going to separate x and y. In general, what I do is follows. I put all the y's on one side, all the x's on another. Let's see what we're going to do here. We're going to divide, and we're going to say dy over 1 plus y is equal to e to the x dx. Okay? So remember, I treat this as a ratio, dy over dx. So I can multiply both sides by dx, and I can completely separate x's from y's. Next step is I'm going to integrate both sides. Okay, so when I integrate this left-hand side here, let's just write this down, dy over 1 plus y is equal to e to the x dx. Integrate both sides. The left-hand side, well, this is just the natural log of 1 plus y. I'm going to assume y is positive in this case, so I won't even put the absolute value around it. It's a natural log of 1 plus y is equal to e to the x plus c. In fact, I could put a plus c on both sides. I could put a c1 on that side, a c2 on that side. But in general, I could subtract c1 from both sides. I'd get the natural log of 1 plus y e to the x plus c2 minus c1. That's just going to be another c, right? So I just put in kind of, it's the protocol to put the constant of integration on one side. Okay, so anyway, I've completed that step. I've integrated both sides. Okay, and that's my result. I've integrated both sides right there. Okay, next. What's the next thing I'm going to do? Well, I want to solve for c here pretty soon. I get f of y is equal to g of x plus c. Again, if you can follow on the left side in general what's going on. Here I've got a function of y right here. I'll take that absolute value and just make it parentheses. I'm going to assume the y is positive. But now I want to solve for c. So I'm going to use initial conditions to find c. Okay, so remember, the initial problem told me that x equal to 0, y equal to 0 is on the curve. So I'm just going to plug into this equation 1 here. And this is going to be the natural log of 1 plus 0 is equal to e to the 0 plus c. The natural log of 1, that's just 0. Let's change up our pens here. This is just going to be 0 is equal to, well, e to the 0 is 1 plus c, which means what? That means c is equal to negative 1. Okay, so I've solved for c. C is equal to negative 1. So now I've got the natural log of 1 plus y is going to be equal to e to the x minus 1. Okay? Well, what do I want to do here? My next thing I want to do is I want to solve for y. I want to isolate y. That's what it's going to say on the next slide here. Oops, nope, maybe not. Oh, we're going to go down a little farther here. Next step, I want to solve for y. And in some sense, I need to take the inverse of both sides. That's what this is saying. How can I get out y from here? Where I'm going to, let's change colors again. We'll go to red, and I'm going to take the e of both sides. So I'm going to take the inverse of both sides. This is a little weird. E to the x. See, I've raised both sides to the e power. What happens to the left side? Well, e to the natural log, these are inverse functions, so I just get 1 plus y is equal to e times e to the x minus 1. What's y going to be? Y is going to be equal to e times e to the x minus 1 minus 1. Okay? So there you go. There's my answer in this case. There's my function of y. If time permits, what could I do? This is a solution. If time permits, I could plug this back in. If I took y and I took, remember, it better satisfy this. dy dx was equal to y plus 1 over e to the x. Okay? If I plug it back in, you'd see it would solve that. Okay? All right, well, let me show you a couple more things, and then we'll maybe work a couple more homework problems. I got 8 minutes here. Here's different forms of diffy-Qs. If I'm showing you these things, we've seen this form before, but I can also write this. I could subtract, with a little bit of algebra, I can get to form number 2. I could also multiply each side by y dx, and I could also get that. So don't get freaked out if you would see a form like this or this. You can still separate, right? Here's the steps. What are we going to do? We're going to separate, integrate. In fact, let's just go through the steps. First thing we do is we separate variables, put x and y on separate sides. Then we're going to integrate variables, integrate both sides, and then we're going to solve for c. Solve for c using the initial conditions, and then we could isolate y. Sometimes you might isolate y in terms of c. You might interchange steps 3 and 4, but those are basically the 4 steps you go through. Okay, let's pull out a homework problem, maybe a little more difficult, and work that. Okay, back with some homework solutions, and you see here I've got a differential equation. I'm trying to find y, trying to find the function. Notice there's no initial condition. No initial condition, so I'm going to get a plus c. I'm going to get a family of functions here. But we can still find that family of functions that satisfy this. First step I'm going to do here is I'm going to separate y, right? I put the y's on the left. First step, separate. Second step, we're going to integrate. And when we integrate, let's rewrite that as a positive exponent. And I can do this. What's the integral of the sine? Well, that's going to be the cosine, right? It's going to be the negative cosine plus c. What's the left side equal to? And we use the power rule here. This is y to the minus 1 over minus 1 equal to that. C, maybe I'd multiply both sides. Let's change pens again. Let's clean this up a little bit. Minus 1 both sides. I'm going to get y to the minus 1 equal to the cosine of x. I could say, I could say minus c here, but remember, I could say minus c, but minus c is just another constant, so it could be plus c again, but I'll leave it minus c for you. But remember, well, you'll see this happen. I'm just changing my c. I call that c1. Okay, this is 1 over y is equal to that. So I can reciprocate both of these things, and I can say y is equal to 1 over the cosine of x plus c. Okay? That function, once again, if I would plug that back into here, it better satisfy it. It better satisfy that, and let me work another problem. Maybe we will plug one in. If you have enough time in a test, you can always verify your solution is correct, is indeed correct. Notice I have a plus c here because I've got no initial condition. So this is going to be a general form. Okay, next differential equation. You'll have a bunch of these to do for homework, nothing like practice. Okay, we're going to separate this, and we're going to, when we separate this, what are we going to do? We're going to take the y's to one side. Okay. I'm going to do a little simplifying over here. That's really 1 over y plus y dy is equal to the cosine of x dx. Okay, so we've separated and simplified. Now we're going to integrate. What's the integral of 1 over y? Well, that's just the natural log of y plus y squared over 2 is equal to the sine of x plus c. Now this is going to be, here's a case where it's not going to be possible. It's not going to be possible to isolate y. So we're going to leave this thing. We are going to solve for c now, though, right? We're going to, but I'm not going to be able to pull out y here. But I have been told when x equals 0, y equals 1. That's what this tells me. And we're going to plug that in. Well, so the ln of 1 plus 1 squared over 2 is equal to the sine of 0 plus c. Okay, well this is equal to 0. This is equal to 1/2. It's equal to sine of 0 is equal to 0 plus c. So c is equal to 1/2 then, right? From this equation here. Okay, so what's our solution? I think we've got it in the bag. Change pens, bring it over here. The natural log of y plus y squared over 2 is equal to the sine of x plus 1/2. Okay, there's my solution. Again, I can't really pull out a y, so we're going to have kind of this implicit function. Y is a function of x, okay? So there's my solution. Okay, but we did demonstrate the steps. We separated the variables y on one side, x is on the other. Then we integrated. So you can see we're going to get lots of practice of integration. In fact, I'd even classify solving differential equations as kind of an application of integration. So you're going to remind yourself how to integrate and solve for C. Okay, hope that made sense. And what I want to do next, one of my favorite parts, is since we know how to solve differential equations, I'll show you how we can derive some of these formulas that you've been using in physics and in math classes or biology classes, and I'll show you how they come from the differential equation. Okay, see you soon.